This is the second part of second video lecture of week 2. Here we discuss in detail about the asymptotes. What is first asymptote? An asymptote is a straight line. Please remember, asymptote is always a straight line that a graph approaches. That means the graph approaches the line, or the line approaches the graph, whatever you say. That means the line and the graph are approaching but not intersect. That means it doesn't touch, but it is approaching. That means it is not equal to A, it is going close to A. Approaches, going close to, but not equal. That means doesn't intersect. So a line is an asymptote to the graph where the line and the graph are approaching but does not intersect. You see here, there are three types of asymptote. Here this dotted is the straight line and this blue is the graph. So what is happening? The graph and the line are closing, approaching, but they does not intersect. That means the graph and the line doesn't touch. So when this line is horizontal, therefore it is known as horizontal asymptote. That means this line is horizontal asymptote to this graph. In another case, we have a graph and we have a vertical line now. When you check this, when you see this graph and the line, so the line and the graph are approaching. That means they are closing, they are coming closer and closer, but they don't touch. So that's why if they touch, it becomes a tangent. Please remember, the opposite of asymptote is the tangent. If they touch, it is a tangent. If they are very close but not touching, then it is an asymptote. So here the line is vertical, therefore it is known as vertical asymptote. Horizontal asymptote and the vertical asymptote. And there is one more which is neither horizontal, that is horizontal, nor vertical. So this is called oblique, or you can say slant asymptote. It is the same. You see, this is the graph and this is the line, and this line is not horizontal, not vertical, therefore it is known as oblique asymptote or slant asymptote. So there are three types of asymptote. So what we do here is, this is all graphical, graphically we understand the asymptote. So means I will not be able to know asymptote whether it is horizontal, vertical and oblique unless until I draw the graph. But graphing is very difficult, therefore there is a mathematical method to find these three asymptote, and here is the formula for that. Identifying asymptote without drawing the graph, without looking at the graph. So how we find or identify the asymptote? The first, to find the vertical asymptote, we are taking denominator equal to 0 and solve. Whatever the value of x you are getting, x is equal to that value is the equation of the vertical asymptote. You understand the method? So set denominator equal to 0 and solve. So x is equal to whatever the value you get. So this is the equation of the straight line, and that equation of the straight line is an asymptote and it is always vertical. Second, horizontal asymptote. So to find the horizontal asymptote, first you have to compare the degree of numerator and the degree of denominator, that means rational functions. So we compare the degree of the numerator and the degree of denominator. If it is less, that is degree of numerator is less than the degree of denominator, you say that y is equal to 0 is the horizontal asymptote. Next, if the degree of the numerator is equal to the degree of denominator, then the what you call horizontal asymptote is y is equal to, you take the highest quotient numerator, highest leading, the first one, leading means the first one, the first quotient numerator, the leading quotient, that is the first quotient denominator, you divide it, so y is equal to that is the horizontal asymptote. So please remember, vertical means x is equal to number, horizontal means y is equal to 0 or y is equal to any number. So remember, the horizontal asymptote exists when the degree of numerator is less than degree of denominator, or when the degree of numerator is equal to degree of denominator. If the third case, if the degree of numerator is greater than the degree of denominator, remember there is no horizontal asymptote. Then what we get? Then we get a slant asymptote. The slant asymptote you will get when the degree of numerator is greater than degree of denominator. Therefore, I here write down slant asymptote. Numerator degree must be exactly 1 greater than the denominator degree. So, the difference between the numerator degree and the denominator degree should be at least 1, right? And the degree of numerator must be greater than the degree of denominator. So, to find this, find the slant asymptote, we perform the long division. That means we divide numerator by the denominator, and we write, and we what you call remove, or we neglect the remainder. So whatever the quotient, so y is equal to quotient, whatever the quotient you get, y is equal to that becomes a slant asymptote. See, x is equal to vertical, y is equal to horizontal, y is equal to is slant asymptote. Let's take one example here. Fx is equal to, this is your function, and I want to find the vertical asymptote. So what I do? I set the denominator 0. So x into x minus phi equal to 0. So then x is equal to 0 and x minus phi equal to 0 means x is equal to phi. So x is equal to 0 and x is equal to phi are the vertical asymptote. If at all, if I am finding the horizontal asymptote, you see, we are taking 3 examples here. The degree of numerator is 1, the degree of denominator is 1. So look at it, they are equal, therefore there is a horizontal asymptote. I will take the degree of this, the leading quotient, that means the leading term, the first term. There is only one term here. So I write here 2x. So what is the the first term of the denominator? It is x. So 2x by x. So I say 2x cancel, 2 by 1. So y is equal to 2 is the horizontal asymptote. In this case, the degree of the numerator is 1, the degree of denominator is 2. So this is lesser. Therefore, here immediately we say that, so the y equal to 0 is the horizontal asymptote according to that rule. In this case, the degree of numerator is 2 and the degree of denominator is 1. This is greater. Therefore, in this case, we don't have a horizontal asymptote. So this is all the rule I have given you here, this. So 0 and it is degree in this case. Let's come to the slant asymptote. Let's determine the slant asymptote of this one. So now you see the degree of x, it is 2, the degree of denominator is 1 greater. So what we will do, we divide it. So 2x square minus 3x divided by this. So I should have the same first term. So I will multiply x into 2x. So x into 2x becomes 2x square. And then minus 2 into 2x is 4x. So the sign of this is this plus and minus, they change, minus and plus. So this cancels. So minus 3x and minus into plus, it is a minus. So we have a minus 3x and we have here this. So minus 3x plus 4x is x. So plus 1, and then we have a what you call the first term is x. So therefore I will multiply this the first term with 1. So x into 1 is x, and minus 2 into this minus 2. So we have here x cancels because they are opposite. So we have here what you call 1 minus 2, that means this becomes plus 1. So 1 plus 2 is 3. This is the remainder and this is the quotient. So I will write here this one fx, which is after division I can write down. So this is the quotient plus the remainder divided by the divisor. So this we can write it like this. So what happens here is that when x is tending to infinity, so this becomes 0. So therefore you will have only this term. So y is equal to 2x plus 1. So I will take only the quotient here, quotient, not this remainder. So I will neglect this. So y equal to 2x plus 1 is the equation of the slant asymptote. And note that here we have a vertical asymptote also, because for a vertical asymptote I have to just substitute the denominator is 0. So x minus 2 equal to 0 gives you x equal to 2. Therefore x is equal to 2 is a vertical asymptote. So we have a slant and the vertical asymptote in this case. So in this case, if this is an example, I will discuss in detail about this, and just go through here what we are going to find out. This is your function. This is application of what you call limit and continuity. So we have this is the function, and we are asked to find the diameter of what you call people at the minimum height and the maximum light. Minimum light means 0. See that? I will find the limit of this as x tending to 0, right? And then I will have to remove this x raised to minus 4. So I will multiply both and then I will get this. And then when x is equal to 0, this is 0, this is 0, 160 by 4 becomes 40 mm, the answer. So for maximum light means x tending to infinity. You see that minimum light means x tending to 0. Maximum light means x tending to infinity. So I will find the limit of this as x tending to infinity. So this becomes 0, this becomes 0, 90 by 15 is 6. So this is what you call application. I will just discuss this in the detail, and this is exercise number 1.5, pages from 103 to 104, and here you are asked to find determine the limit, whether it is plus infinity, minus infinity, or does not exist. So check this and try to find out this one. So here you are going to find whether you are going to find all the horizontal and vertical asymptote for these examples, and for this vertical and slant asymptote, and this is the example which I discuss in this case only. So more detail we will discuss in detail in the live class. And what we studied in this part is that we have studied for limits involving infinity and 3 types of asymptote, and the application, I mean some example we have done using limit, asymptote and all. So I will be uploading some additional questions also, and more detail we will continue in the live class. So keep ready the questions for the live class, and in the live class I will be